The James Webb Telescope discovered something strange at the edge of the universe. The universe is a big place, really big in fact, that we will never be able to explore all of it. There's just too much ground to cover, but that doesn't mean we can't try. And one way we can do that is by sending space telescopes into orbit. NASA's most recent space telescope, the James Webb, is currently in orbit around Earth and is already giving us glimpses of parts of the cosmos we've never seen before. One of its targets is the very edge of the universe, and what the telescope has observed there is truly startling. What exactly did the telescope see at the edge of the universe, and how does it affect you and me? In the centuries since the telescope was invented, we have made great strides in understanding the universe. We have discovered that our universe is not the only one. There are an infinite number of parallel universes, each with its own set of laws and constants. We also have discovered that our universe is expanding and that it will eventually end in a big freeze. The invention of the telescope was a key moment in the history of astronomy. The telescope allowed us to see further into the cosmos than ever before and begin to unlock the mysteries of the universe. While the concept of telescopes was known in the late 16th century, the first telescopes were not made until 1608 in the Netherlands. The telescope revolutionized our understanding of the universe and continues to play a vital role in astronomy today. Galileo's story is a great example of how powerful a tool telescope can be in changing our understanding of the universe. Early telescopes were used for making observations on Earth, but Galileo Galilei was one of the first astronomers to aim his telescope toward the heavens. Galileo's story demonstrates how a tool for collecting information can be used to change our understanding of the universe. Galileo's improvements to the telescope allowed him to make many discoveries about the universe that were previously hidden from view. Through his observations, he was able to confirm many of the theories of Copernicus and disprove the prevailing view that the Earth was the center of the universe. Galileo's work laid the foundation for our modern understanding of the cosmos. Now, the vastness of space is one of the main reasons why we need telescopes. Without telescopes, we would be limited to only seeing the things that are close to us, like the planets in our solar system. But with telescopes, we can see much more distant objects, like stars, galaxies, and even nebulae. Telescopes allow us to explore the universe and learn more about its mysteries. They also give us a way to appreciate the beauty of the universe. Space and telescopes are inseparable due to the vastness of space. For example, the star closest to us is Proxima Centauri, located approximately 4.2 light-years away. This translates to a distance of 25 trillion miles between Proxima Centauri and Earth. Even though Mars, the planet Elon Musk is attempting to colonize, is closer than Proxima Centauri, volunteers will still have to undertake a long journey through space before they can start living on Mars. The Hubble Space Telescope has been one of the most important tools for astronomers in the last century. It has allowed us to see things that we never thought possible and has helped us to understand the universe in a whole new way. While the Hubble is an amazing instrument, it is not the only telescope that we use to study the universe. As our technology improves, we are able to see further and further into space. The most recent high-power telescope is the James Webb Space Telescope. The James Webb Space Telescope, JWST, is a large infrared optimized space telescope designed to observe the most distant and oldest objects in the universe. It will be the premier observatory of the next decade, providing insight into the history of our universe from the first light after the Big Bang through the emergence of solar systems that may support life on planets like Earth and the evolution of our own solar system. The telescope features a number of powerful instruments, including 4 sensitive cameras and 2 spectrometers. One of the spectrometers, NIRSpec, includes configurable microshutters that allow it to observe up to 100 objects at the same time. Webb also features a cryocooler for cooling another instrument's mid-infrared detectors to a very cold 7 Kelvin, allowing them to function properly. This telescope is so powerful that it will be able to see things at the edge of the universe that we have never been able to see before. With this new information, we may finally be able to understand what goes on at the very edge of the universe. What evidence do we have for the existence of things beyond the observable universe? If we trust that the laws of physics as we know them apply to the universe as a whole, we can extrapolate from what we observe to make predictions about what exists beyond our observable universe. For example, We can use the observed flatness of the universe to infer that it is infinite in extent. Or we can use measurements of the cosmic microwave background to establish that the universe is at least 46.5 billion light-years in diameter. Of course, we can never be 100% sure that our extrapolations are correct. But by using the best available data and applying known physical principles, we can make educated guesses about the size and shape of the universe. And as our understanding of the universe expands, so too will our ability to make ever more accurate predictions about what lies beyond our observable universe. The two main sources of data for this extrapolation are the Sloan Digital Sky Survey and the Planck satellite. The former mapped out the large-scale structure of the cosmos using a telescope in New Mexico, while the latter measured the cosmic microwave background, CMB, with a telescope in space. Both of these sources of data imply that the universe is at least 250 times larger than the part that we can see. This means that the total diameter of the universe is at least 23 trillion light-years, and the volume of space is more than 15 million times larger than what we can observe. However, there are also convincing arguments that the actual size of the universe is much, much larger than what these two sources of data imply. Now, the most distant astronomical object that human can see is the cosmic event horizon of the universe. This is the point beyond which light has not had enough time to reach Earth. Beyond the cosmic event horizon, the universe is effectively hidden from us. But why can't we see beyond the cosmic event horizon? It's not because we lack the technology to do so. The reason that the universe is expanding too fast for light to reach us from those distances. As the universe expands, the space between us and the farthest object gets bigger and bigger, effectively pushing them beyond our reach. However, telescopes such as the JWST allow us to look much farther. The GN-Z11 galaxy is the most distant galaxy ever detected. At about 46 billion light-years away from Earth, it is the furthest point in space and time that humans can observe. Beyond this point is what is known as the opaque universe, a region of space that is beyond our ability to see. Despite its name, the GN-Z11 galaxy is not the end of the universe. There is still much that we do not know about the cosmos and what lies beyond our observable universe. However, the GN-Z11 galaxy is a remarkable discovery that gives us a glimpse into the vastness of the universe and the mysteries that it holds. It is currently unknown whether the universe is infinite or not. If the universe is infinite, then it is also unbounded. This means that there is no edge to the universe and no center. All points in the universe are equivalent. If the universe is not infinite, then it is bounded. This means that there is an edge to the universe and a center. The center of the universe would be the point from which the Big Bang occurred. All points in the universe are not equivalent. The size of the universe depends on the answer to this question. If the universe is infinite, then it has no size. If the universe is bounded, then it has a size. The currently adopted size of the universe is about 93 billion light-years in diameter. The universe's edge is an ever-expanding boundary that is moving away from us faster than the speed of light. Beyond this boundary lies an unknowable void. What lies beyond the event's horizon is a mystery, as it is an unreachable place for us. The edge of the cosmos is defined by a particle horizon, which is similar to the event's horizon of a black hole, except inverted. It's essential to understand, though, that the universe's edge does not exist in the way you might think. How? The best way to conceive of the edge of the universe is probably not in terms of space, which explains why even if you were to catch up to it, there would just be more universe. You might imagine it as a place where you could turn around and see a zoomed-out view of everything, including every galaxy, planet, star, etc. The universe is a self-contained system, according to the theory, which means that there is no edge. Instead, it is infinite in size. This presents a problem for those of us who like to think of the universe as an object that we can observe from the outside. Without an edge, there is no outside. This theory also has implications for interstellar travel. If there is no edge to the universe, then it is impossible to reach outside. This means that even if we could travel faster than the speed of light, we would never be able to leave the universe. We would be confined to it forever. What do you think the edge of the universe looks like? Let us know in the comments.